Today we will discuss about the Coulomb's law again, but this time we will discuss the Coulomb's law in the vector form. We will discuss the Coulomb's law in the vector form. Earlier we have discussed the Coulomb law also, but that was in the scalar form.
Yes, sir.
I have just told you the magnitude there in the first class. I have discussed this is the Coulomb's law, and I have asked you yesterday also, I think, the Coulomb's law. So listen first. The Coulomb's law is nothing but it is the expression for finding the force between 2 point charges placed in any medium. Nothing. And the formula of the Coulomb's law of force is F is equal to K product of two charges divided by the distance square of distance between two charges. Suppose if you have a charge q1 here, another charge q2 here, these q1 and q2 are the point charges and they are separated by a distance r, then the force between two charges, if they are positive, the force will be like this. If they are negative, the force will be like this. Accordingly you will write, and the value of that force is given by this: F is equal to k q1 q2 divided by r square. This is a Coulomb's law. And the value of k, if these two charges are placed in air, you will write 1 upon 4 pi epsilon naught. Okay, and the value of this k is 9 into 10 to the power 9 in SI unit. So this is all about the Coulomb's law in the scalar form. Now we are just uh, discuss about the Coulomb's law in vector form. In the vector form. So before that, I want to tell you about the position vector and the displacement vector. Position vector and the displacement vector. So please concentrate. Position vector. So the position means, suppose this point, suppose this is a point in my hand. This point is here. Now
Yes.
the position change. This point
Yes.
is here. Now again the position change.
Yes.
Position change. And you are at a different position, I am at a different position. So what we
Yes.
will do, we will calculate the vector of the position. Simple. So let's see what I will do. I will take two coordinate axes. This vertical axis is y-axis and this horizontal axis is x-axis. Suppose if I am taking a point, suppose you can choose any point on this axis. I am just choosing one point here. Okay. This is any point,
Yes, sir.
location of any point, or you can say position of any point. So if I am just drawing a line from the origin to here,
Yes.
and this will become vector. Now this has
Yes.
the arrow and this has the tail and this is the origin. This is the position vector. This is the position vector of, if suppose this is a point A, then you will say this is r suffix a vector, and r suffix a vector will be the position vector of point A. Nothing is there in position vector. So this is position vector of point A. You can take any other point also. If you can also find the position vector of any other point. Suppose here is a point, here is another point B. So if you want to find the position vector, what you will do? You will join this vector, join this point with the origin
Yes, sir.
and make an arrow like this. Means this arrow is showing the direction. So this is the position vector of point V.
Yes, sir.
So R suffix V vector will be the position vector of point V. Position vector of point B. Very good. And if you want to find the length of this distance OA, means OA, what is OA? OA will be the magnitude. This is the vector, na? This RA is the vector, and I have told you vector have the magnitude and the direction. So if
Yes.
you want to find this thing, mod of this, then I have already told you the mod of this will be the magnitude of vector RA vector. The magnitude, this will tell you. So this is all about the position vector. Now we will discuss about the displacement vector. Displacement means displacing something. Suppose this point is here now. Now I have just put this point here. So means there is a displacement between 2 points.
Yes, sir.
So and we will make the vector of that. That will become the displacement vector. So I am just using this figure again. So write the heading displacement vector. This is now see what is displacement vector. No need of this. We already know this. So what is happening here? This is the position vector of point A. This is the position vector of point B. And suppose if you are moving from point A to B, if you are moving from point A to B like this, if you are earlier you were at here and
Yes.
now you are traveling like this, like this, like this, now you are here. So this AB is the position vector, so not the position vector. RAB will be the displacement vector. Okay. So
Okay.
this RAV is the displacement vector. So displacement vector is if you are moving from one position to another position, then you will get the displacement vector.
Okay.
And one thing more I want to write about the displacement vector. This displacement vector RAV vector, this can be written in the terms of RA minus RB. RA vector minus RB
B.
vector. If you want to find the magnitude, I have told you for the vector magnitude you will write like this modulus, and modulus of this you can also do RA minus RB. So this will tell you the magnitude of displacement.
Yes, sir.
So now we will discuss the Coulomb's law in the vector form. We will use these things there. Coulomb's law in vector form. So for the Coulomb's law, there will be a requirement of two charges. There will be a requirement of two charges. So what I am doing, we know that RAV is the displacement vector, and this is x-axis, this is y-axis, and now I am saying, suppose a charge q1 is placed here at this position. At point A, now I have placed the charge q1, and
Yes,
at
sir.
point B, I have placed a charge q2. And these both the charges are the positive charges. These both the charges are positive charges, and
Yes,
the
sir.
distance between these two charges is you can take the magnitude of this, then you will get the distance. You can
Okay.
say the distance between the two charges is, there is a difference between the distance and the displacement.
Yes, sir.
Yeah. So distance between two charges, if you want to write, then you will take the magnitude of this, and I will write the magnitude of this. I have told you like this. This magnitude of the position vector will give you the distance between the two charges.
Okay,
So
sir.
again, these are 2-point charges. Again, these are 2-point charges, I have told you, and these point charges will repel each other with some force.
Yes, sir.
Suppose this charge apply a force on B with respect to A. On B, force on B,
With respect to it.
yeah, or you can say force on B due to A. And
Okay.
again, on this charge also there will be a force.
Yes, sir.
That will be a force at charge at A due to B.
Okay, yes, sir.
Fine. And we know that if we want to calculate the FBA or FAB will be equal in magnitude.
Yes, sir.
In magnitude, both forces FAB is equal to FBA, and that is equal to the force between the two charges that is separated by this distance will be K Q1 Q2 divided by, what is the distance between the two charges this time? RAB.
RAB.
Vector and the mod and the
Yes.
square of this.
Yes.
Okay. Fine. Is it clear now?
Yes, sir.
I have done nothing special. The earlier the distance I have taken R, now the distance is again R, but now I have just
In
written in
modulus.
some different form.
Yes, sir.
In some different form, in the modular form. The concept will always remain same. The Coulomb's law will always remain same, but we have to convert that in the vector form.
Okay,
And
sir.
I have told you, if you want to calculate the, suppose we have a vector of RAV vector, we have this vector, and we want to find the unit vector unit vector of RAV vector if I want to find. So I have told you for the unit vector you will write RAV vector. Sorry, for the unit vector you will write you can do this. Unit vector is represented by this cap on the vector. So you can write unit vector as RAV vector divided by the magnitude of RAV vector. We have discussed this. If we want to write the, suppose I want to write the force vector magnitude, means unit vector of force vector, then I will write the force vector divided by the magnitude of force vector. Magnitude of
Force vector.
So from here, if you want to write RAV, if you want to write from here, then you will write RAV vector into this vector, unit vector of RAV. You will write this. So accordingly, if you want to write the force vector in the vector form, AB, FAB in the vector form, so what you will do, first you will write the force AB vector, then you will write the magnitude of force AB. This is the magnitude of force AB, and what you will do, this is the special point, you will write the unit vector. You will write the unit vector in the direction of AB vector. So unit vector in the direction of AB vector is RAV.
Yes, sir.
So you can remove this. I was just so RAV. See here, this RAV
Yes.
is a vector in the direction of AB, but this RAV vector, not this RAV vector is the unit vector in the direction of AB. Okay, I will tell you this with some different way. Are you getting this or not?
Yes, sir.
Okay. Actually, see here, we have this force FAB.
Yes, sir.
Now we want to convert this FAB in terms of vector. So do one thing. Write FAB vector you want to find now.
Yes, sir.
Then what you will do, you will just first write the magnitude of FAB and multiply it with the unit vector in the direction of
FAB.
AB, and that is RAV.
Okay, sir.
Okay, fine. So now I am writing value of FAB. FAB is K Q1 Q2 divided by RAB
AB
vector and the square, and unit vector is written like this, RAB divided by RAB vector.
Okay.
Means RAB, this is the vector and the mod of RAB. Now you can write FAB KQ1 Q2 Q1 Q2 and this RAB vector divided by, this will become cube of this. This is RAB vector square, and this, when you multiply this with this, you will get RAB vector and the cube of this.
Oh, yes, sir.
And I have already told you, for RAB you can write RA minus RB. For RAB, you can write RA vector minus RB vector.
Okay, sir.
So for FAB vector, you will write KQ1 Q2 divided by KQ1 Q2. You will write, instead of this, R A vector minus R suffix V vector,
Yes, sir.
and divided by, you can again write this here, R A vector minus R V vector and the cube of this. This is the Coulomb's law of force in the vector form. This is the representation of Coulomb's law in the vector form.
Okay, sir.
If you want to write the FVA, if you want to write FVA, same thing you will do. Same thing you will do.
Okay, sir.
If you want to write for FVA,
Sir?
yeah.
So why do we split AB?
Because you can read the question in terms of position vector of A, in terms of position vector of B.
Okay, okay, sir.
Actually, the main reason of this is just the, if vector can be written in this form also.
Yes,
This is
sir.
one of the form. But sometimes in the question you will get the position vector of A, then and position vector of B. Then you will use this formula for calculating.
Oh, okay, sir.
Okay,
Okay, sir. Yes.
that
Okay.
is why I have splitted this. Otherwise there is no requirement of this. Means there is no hard and fast rule to write the Coulomb's law in this form, in
Okay,
vector
sir.
form. You can
Okay.
write in this form also.
Okay, sir.
So for FVA vector, we have calculated FAB. FAB
Yes, sir.
vector we have calculated.
Yes, sir.
Now we will calculate FBA vector.
Yes.
For FBA vector, I have told you, first write the vector and magnitude of FBA and unit vector of BA. This time you are taking the unit vector of BA vector.
Yes, sir.
Then you will write the R. Now this time not AB, you will take RBA vector and the magnitude of RBA vector.
Yes.
So for calculating FBA magnitude of FBA, we know that KQ1 Q2 divided by, this is the thing I have written here,
RB.
RAB square.
Yes, sir.
And one thing I want to clear, as this RAB, the magnitude of RAB and RBA is same, because magnitude means length
Yes,
of
sir.
AB, length of AB will be same.
Yeah, yes, sir.
RAB, okay, you can write distance between the two vector as RBA vector magnitude, like this
Okay.
also.
Okay,
So
sir.
instead of this, you can write this formula in this form also. KQ1 Q2 divided by RBA vector
Yes,
and the
sir.
square of this, and you will use according to your requirement. So we will use
Okay,
here
sir.
according to our requirement. So KQ1 Q2 divided by R vector, and we will take this time the square of BA.
BA. Yes, sir.
Mod square of this, and we will multiply this RBA
Yes, sir.
and this the mod of RBA.
RBA. Yes, sir.
Yeah. So when you will further solve this, you will get KQ1 Q2. You can write this RB minus RA divided by, this will become cube of this RBA.
Yes, sir.
So you can
RBA
write
cube.
this RB
RBA
vector
vector
minus RA vector and the cube of this. So you will get F B A this. In this form you will get the Coulomb's law in the vector form. So actually this is just the not about the Coulomb's law, just we were playing the game of vectors here. Nothing else we are doing.
Okay. Yeah.
Slowly you can do this when after the practice, and so now you can note it down.
Okay, sir.
This is just the game of the vectors.
So can you scroll down?
Ziyad, your class timing is fixed, na?
Yes, sir.
Means your class will be on Saturday and Sunday at the same time.
It might change, sir, because my schools are reopening. That's why. I might change the timing. Sir, can you take class in the evening?
Evening means what is the time?
Maybe
You tell
around
me.
like 5 or 6 p.m., sir. Like according to the Kuwait time, sir.
Oh, you are in where are you right now?
Kuwait, sir.
So actually that thing is not in my hand. You have to talk to the Learnivio team. Okay?
Okay, okay, sir.
Yeah. They will decide the timings. I cannot decide.
Okay, sir.
Yeah. You can ask for the time change and all the queries you are getting. So
Yeah, okay, sir. So can you scroll down?
what is the time there right now?
3-7, sir.
3, 7. Here is
It's
5.
2.5 for difference.
Yeah, here is 537.
Yes.
You can uh, you can ask for the time change from the Learnivio team.
Okay.
Yeah. For this chapter, electrostatics, and you should have actually a basic command on the vector. Not much. I am not saying much command on the vectors. You should know at least what is the position vector, and how the addition of the vector, and some special cases of the vector addition. You should know at least these things. Then this chapter will come to you.
Okay, sir.
Yeah. And this thing is not very complex thing, a very easy thing. When you first you will get understand, then things will be very easy for you.
Okay, sir. So can you scroll down?
This is the cap.
Yes, sir.
Oh, we will solve one question on this Coulomb's law in vector form
Okay, sir.
without using this formula.
Okay, sir.
But you can learn this formula like F. This is FBA. So K Q1 Q2 are BA. This is BA and this is BA. This
Yes,
is AB here, AB here. But uh, if you want, then you can learn. But I will solve the question without using this formula.
okay.
I will use the basic concepts of vector
Okay,
for
sir.
solving it. In physics, I am telling you one thing. Formulas are not important. You have to feel and understand the thing.
So it's the exact opposite for us in the school, sir. For like in my
I
case.
I don't know actually I was you are right. In my school also there was certain things when I was in 12th class. But the thing is, when you will grow up, then you will get to know it. Formulas have nothing. Means there are in 80% cases there are no use of formulas and all that. You know the basic formula, what is the electric field and what is the force and all that. But
Yes.
formula will not always help. Formula helps you, but not always. You have to understand the thing, na? Where the force
Yes,
is
sir.
going, where is the direction of the force. I can also write this Coulomb's law in vector form. Ziyad, write this. I was copy this and write here. Write this. This is the uh, Coulomb's law in vector form. Don't need of this position vector. Why we are wasting time in position vector, displacement vector, and all these things? Because
So it's the
I
exact opposite for us, sir. It's the exact opposite.
but I just deny that system. I don't think that system is worth for the students.
They
This
don't
is
teach the concept properly, sir. They're like half, like, sir.
I actually I am just denying those things. Actually, they are just doing whatever they are doing. But my concept is this: first understand, and after that, if you want to learn any formula, then you can learn
Yeah, sir.
formula.
This is
If you are,
the correct
if I
way.
am teaching, I am teaching you that 100 things if I am teaching. Suppose you are getting 25 things, but with understanding now.
Yes, sir.
With understanding, if you are getting out of 100 things, 25 things with understanding, you feel good. And if
Yes,
just
sir.
I am writing formulas and that forcing in your mind and learn the formulas and all that, you will get bored after a period of time. But
Yes, sir. That's true,
yeah,
sir.
I can also write this in the very simple form. My time is also will be saved. My time will also be, I
Yes, sir.
don't want you to. But the students in uh, today's students, I will say, like the shortcuts for the success. But there are no shortcuts. I believe that.
So time in the boards exam is very precious, sir. So you have to take the shortcuts on it, sir.
No, not. I am not saying that thing. Time is, but you when you will solve the question paper of board examination, na,
Yes, sir.
they will always they uh, the motive of the examination is not to mugging up the formulas. They also know that you will use the things. You will get shortcuts automatically when you will get through the concepts.
Yes, sir. That's true, sir.
Just you can see, I will solve the next question without using this formula.
Okay, sir.
So these kinds of shortcuts will be generated only when you know the concepts.
Yeah, okay, sir.
Yeah.
Finished, sir.
Yeah. Completed na?
Yes, sir. Finished.
Yeah. Time is very important. You have to complete the question in the minimum possible time.
Yes, sir, that's true.
Yeah. Two charges plus 3 microcoulomb and minus 6 microcoulomb are placed at 2, 1, 0 and 3, 0, 0, and they are given in meter. Position vectors. Calculate force on minus 6 microcoulomb charge. So two charges, 2-point charges are given to us.
Yes, sir.
2-point charges are given to us simply like the, but this time they have given the position of these charges. First charge plus 3 microcoulomb is placed somewhere 1, 0 and another charge is placed somewhere 3, 0, 0. This is just a rough diagram,
Okay.
and here are plus 3 microcoulomb charge is placed, and here minus 6 millicoulomb charge is placed.
Okay, sir.
6 millicoulomb charge is placed. Now see here, they are asking the force on this charge. So this is positive charge, this is negative charge. So the
It's
force
going
will be in this
opposite.
direction.
Yes, sir. Left side.
We have to find this force. Okay. So what you should do, first you should write the position vector of this, position vector of this. So I am supposing this as point A, this as point B. Okay.
Okay, sir.
So if you want to write the position vector of any point, if you want to write the position vector of any point, if the coordinates are given, then if you want to write RA vector, then you will write 2 I cap plus
Yes, sir. I.
j cap and
Okay,
0.
G cap.
The 0 is there, so you will not write the k cap form.
Okay, sir. Yeah.
If you
Okay.
want to write RB, then
3
you
I
can
cap.
just write 3 I cap only.
Okay, sir.
Why I am doing this? Actually, the thing is that I am supposing somewhere here the origin, and
Yes,
I am
sir.
subtracting this 2 minus 0 I cap, 1 minus 0 j cap, 0 minus 0, so there is no k cap. So
Yes, sir.
what I am doing, this thing I am doing, that's how I am writing the position vector with
Okay, sir.
respect to origin. So I have done, this is origin, so I am
Yes, sir.
minusing this 3 minus 0 I cap, and now all the things are 0, 0, so there is no. So now we know that the if I want to find RAV vector, so I can write RA minus RB.
Sir,
Yeah,
origin can be anywhere, right?
yeah, you can actually origin can be anywhere. You can suppose the origin here also.
Okay, sir.
Actually, this is the rough diagram now. That is why
Yes,
I
sir.
am supposing the origin. You can take the origin here also. There is no problem.
Okay, sir.
Actually, this is not the exact position. You have seen the graph paper. Have you seen the graph paper now?
Yes, sir.
So we can only draw the exact points on the graph. In
Yes,
the
sir.
paper, for the understanding purpose, we draw like suppose the origin is here and all that.
Okay,
Okay.
sir. Okay.
But actual thing will be done on the graph paper. So
Okay, sir.
our motive is to solve the question. So
Yes, sir.
so RA vector, what is the RA vector? This is RA vector 2 I cap plus
Yes. J.
j
G
cap
cap.
minus 3 I cap. So
Yes, sir.
now you will get this 2 I cap minus 3 I cap means I cap you will get plus j cap you will get, and you will get the RAV vector.
Yes, sir.
Now what is RAV? RAV is the distance
Yes, sir.
between 2 points. If you will take the magnitude of this
Yes.
distance between 2 points, I have told you. So
Yes, sir.
calculate the magnitude of RAV. So for the magnitude of this, what you will do, you will the square of the coefficient of this. This minus 1 square
Yes,
means the
sir.
coefficient of this 1, and you will write here 1 square. Then you will get the under root 2. Under root 2 you will get. And
Yes, sir.
okay. And if you want to find the force, value of force, then you will write K Q1 Q2 divided by the distance between them square, means R AB mod square.
Yes,
So
sir.
the value of K, you can take the value of K, we will have 9 into 10 to the power 9,
Yes, sir.
and the value of Q1 is 3 into 10 to the power minus 3. I am just changing this millicoulomb into coulomb. 1 millicoulomb is equal to 10 to the power minus 3 coulomb.
Yeah, okay, sir.
3 mc means 3 into 10 to the power minus 3 coulomb. And here we have 6 into 10 to the power minus 3. I am not taking the sign because I have already taken the direction.
Okay, sir.
So
Okay.
6 into 10 to the power minus 3, and the distance is root 2 square.
Yes, sir.
So you will get this. This will become 172. Huh? 162. You will get 162 into 10 to the power. This will become 10 to the power 9 minus 3 and minus 3. 10 to the power 3. You will get. Okay. And square of root 2 will become 2.
Yes, sir.
Okay. Now cancel it out. When you will cancel it out, you will get
81.
281, means 81 into 10 to the power 3. You will
Okay.
get the force,
Sorry, 3.
magnitude of force as this, Newton.
Okay.
Now you want to find this force. This is for A and this is B.
Yes, sir.
So you have calculated the magnitude. This is the magnitude of force you have calculated.
Yes, sir.
Now you want this F vector. So I have told you, for writing any vector, first you will write the magnitude of vector, that vector, and
Yes,
the
sir.
unit vector in this direction. Unit vector in the direction of that vector. Unit vector in the direction of that vector,
Yes, sir.
RBA.
Yes, sir.
Okay. So
Yes.
RBA we can calculate very easily. RBA, we have RB minus RA, means this will become 3I minus 2I, means I
Yes.
minus J.
Yes, sir.
RBA will become I vector minus J vector. Are you getting now how I have calculated this RBA? I have just subtracted this from this.
Okay, sir. Okay. Yeah.
Subtracted this from this.
Yeah, I understand, sir. Yeah.
From here I have calculated RBA. Okay.
Okay, sir.
Yeah. So this is the, and now if you want to calculate the unit vector, so you also have to calculate the magnitude of RBA. That will become again 1 plus minus 1 square. It will become under root. Then you will get the RBA vector unit vector as RBA vector divided by the magnitude of RBA vector. So what is RBA vector? This is RBA vector, I minus J
Yes, sir.
cap and this. So
Those
you
two.
will write force as, you have the magnitude of force as this 81
Yes, sir.
into 10 to the power 3,
Yes.
and unit vector in this direction of BA. This is the direction BA, na? BA, in this direction you have unit vector.
Yes, sir.
In this direction you have a unit vector RBA, unit
RBA.
vector and you will multiply it. And what is the value of RBA? I minus j.
I minus j by root 2.
I minus j divided by
Root 2.
root 2. This is your answer.
Okay.
And this is the value. This is the force. So you can write this 81 divided by root 2 into 10 to the power 3 I minus
Minus
j.
j.
I have not used that formula.
Okay.
We got the answer. Okay, now you cannot note it down. Scrolling up.
So if we use that formula, we'll get the same answer, right?
Yeah, of course. Of course, we will. You should try that at your home. Okay.
Okay.
Actually, we have a limited time, so I cannot do the question again and again. Have you written the question?
Yes, sir, I have.
Okay, so
Second, scroll down.
if you want to calculate with the help of formula, just you can apply the formula of FBA simply,
Okay, sir.
and you can write the position vector of A instead of RA and position vector of B instead of RB. You will get the same answer.
Okay, sir. Okay.
Yeah.
Second, scroll down.
We have a class of 1 hour and 30 minutes. Yeah?
Yes, sir.
Okay. Now we will start the electric field.
Okay, sir. finished.
Should I scroll down?
Yes.
No,
Yeah, finish this part, sir.
yeah. Finished now?
Yeah.
So now we will start the electric field. So see what is the electric field? Electric field is generated due to the charge.
Yes,
Due to
sir.
the negative charge, the electric field. Field means the space.
Yes, sir.
Field means the space. Suppose I am having this charge. This charge creates a field, means
Yes, sir.
a region around itself. Region
Yeah.
around itself. So that if any other external charge will come into it, then that charge will experience a force.
Okay, sir.
So electric field. So first I am just writing the definition. The space around the charge. The space or region around a charge. The space or a region around a charge in which another charge experiences an electric force so we will see what is happening, why the electric field is, what is the significance of the electric field. Suppose I am having this capital Q charge here,
Yes, sir.
and I am having a Q naught. This Q naught is known as the test charge. This charge is used to test the electric field due to this charge. And this test charge is very, very small, very, very small.
Okay, sir.
So we know that from the Coulomb's law, this is a point charge and this is also a point charge. In between two point charges, there is a force of interaction,
Yes, sir.
and that force of interaction is given by K, the product of two charges, Q into Q naught divided by distance, means you can take distance this as R distance between the two charges, and I want to find the electric field here at this point P, and at this point P a test charge is placed, and this test charge is very, very small. So see here, first you will calculate the force. We know the Coulomb's law,
Yes,
K
sir.
Q naught by R square,
Yes.
and the electric field is given by force between the two charges and divided by the test charge is the electric field. So you will write K Q naught divided by R square, and you will divide it by Q naught, and this Q naught and Q naught will get cancel out.
Yes, sir.
You will get the value of electric field at a point will be KQ divided by R square. So this is the electric field. This is the electric field, magnitude of electric field. This is the magnitude. So if we will talking about the direction, if I am talking about the direction, this is a test charge. If I want to talk about the direction, so see how we will calculate the direction. We will calculate the direction with the help of, I am just telling again, this Q naught is a test charge. Na? This Q
Yes,
naught
sir.
is a test charge.
Okay.
Don't forget it. And we will now see what will be the what will be the direction of the electric field at this point P? This test charge is here. So, yeah, okay, no problem. This test charge is placed at point P. Now we will see what is the direction. So I am taking this test charge is positive,
Okay.
and this charge is known as test charge, and this charge is known as source charge. And this source charge is again positive.
Okay.
So due to this charge, if according to the Coulomb's law, the direction of force will be in this direction,
Yes, sir.
and that direction of force is same as that of direction of electric field. Means due to the positive charge, the direction of electric field at any point will be away from the charge.
Okay,
Will
sir.
be away from the charge.
Away from the charge.
Okay. Now take another point. You can take another point here. Means if you want to suppose calculate the direction of electric magnitude and direction of electric field at any other point from this charge. This is a source charge, and
Yes, sir.
this is again at a distance of r from this charge. And what you will do, you will take a test charge q naught here, and same thing you will do. First you will calculate the force due to this
Yes, sir.
charge and divide it by test charge. You will get the electric field at this point. You will get the electric field at this point. And what will the direction of electric field? Will be in this direction, away
Upwards.
from this point,
Away from source charge.
because the electric force will be away from this point. And
Yes, sir.
see here the electric field is forced by q naught. And if you want to write the electric field in the vector form in terms of force, then you can write force vector divided by q naught, and q naught is the test charge.
Okay, sir.
So this is the electric field intensity. We will discuss this. So this is just the basics of electric field.
Okay.
So now I am just writing some terms here. Here F is the electric force. On test charge q naught. And r, what is r? R is the distance between the source charge and this. So I am just discussing this here.
Okay, sir.
So if you want to find the electric field strength or electric field intensity, then now one thing more I want to tell you. Definition, if you want to write the exact definition of electric field, this is one of the definition. You can say the space or a region around a charge in which another charge experiences an electric force. This is the definition. Or you can write the definition in another way. You know that the electric field can be written in terms of force like this. E is the electric field, F is the force on the test charge, and
Yes,
Q
sir.
naught, E is the electric field. Okay. And F vector is a force on
Yes.
test charge. Test charge Q naught. And Q naught is a test charge which is very, very small.
Yes, sir.
I have already told you. So if you are taking force as if you are taking charge as test charge is equal to 1 coulomb. If you are taking test charge as 1 coulomb, then you can write this electric field is equal to F divided by 1. So means you can write electric field is equal to force vector.
Yes, sir.
So you can define the electric field as electric field is the force experienced by the unit positive test charge, unit positive test charge at a point. So this is one of the way to define the electric field. So another definition of electric field is the electric field is the force experienced by the test charge. So now I am writing the SI unit of electric field. SI unit of electric field is Newton per Coulomb or volt per meter. Volt per meter is the SI unit. Now what we will do, we will just calculate the electric field intensity. Electric field intensity, or you can say electric field intensity, you can say electric field strength, or you can say flux density, electric flux density.
Yes, sir.
Electric field intensity or electric strength or electric flux density. This have three names: density, for a point charge. Point charge. So now you have a point charge. This you have a charge Q. This is a point charge, and you want to calculate the electric field here at this point P. You want to calculate the electric field, and you have this point charge as positive charge. So how you will calculate the electric field, I have already told you, but I am just telling it again. Take a test charge Q naught here and calculate the force on this test charge at a distance r. You want to calculate the electric field at point P, which is at a distance r, and
Yes,
now
sir.
place a test charge Q naught at a distance r. Calculate the force Q naught divided by r square, and if you want to calculate the electric field, then divide, right? We have the formula.
Yes, sir.
So force is Q naught by r square into Q naught, and Q naught will be get cancel out. Then you will get the electric field intensity at a point r, KQ divided by r square. This is the formula I have already discussed. Just
Yes,
now you will remember this formula. If you want to calculate the electric field at a point which is a distance r, then you will, due to a charge point charge q, then it will be KQ divided by r square. Yeah. And if you want to write this electric field in the vector form, so what you will do? First you will take the vector of electric field, and then this is the magnitude now.
Yes, sir.
So write the magnitude of electric field. KQ divided by, sorry, K, this is capital Q divided by R square. And you will take the position vector in the direction of this electric field. Electric field will be in this direction due to the positive charge.
Yes, sir.
And take the position unit vector of R in this direction. So you will get the electric field in the vector form also. So, and see here we have the electric field is inversely proportional to 1 by r. From here, k is constant, q is constant, and electric field is inversely proportional to 1 by r square. So if you will draw the graph between the electric field and the distance, how the electric field will change when distance is changed from the charge, then you will get this kind of graph. Means this is the rectangular hyperbola type of graph.
Yes, sir.
Okay, this kind of graph. You means as the distance is increasing, the electric field is decreasing.
Yes, sir.
Yeah. So one more point I want to add. I have already told you the direction, but I am writing it again. Direction of field. Field means here electric field. The direction of field, you can say same as that of electric force. Of electric force experienced by test charge. Why test charge? Now I will ask you some question. If we have a this negative q charge, and here is a point, and I want to find the direction of electric field at this point. I want to find the electric field at this point. So what you will do? You will take a test charge. You will just
Yes, sir.
imagine in your mind. Here a positive charge is placed. Imagine in your mind here
Yes,
a
sir.
unit positive charge is placed, and if a positive charge is placed here, then due to this negative charge, the direction of force will be in this direction.
Yes, sir.
So same is the direction of electric field.
Okay, sir.
Fine. Now you can note it down. From where you want to note it down? From the electric field, now starting.
Yes, sir.
Okay. Okay. This. So electric field is basically the region or the space around the charge in which a test charge experiences a electric force.
Electric force. Yes, sir.
And this r is a distance between this point, this charge, source charge, and this point P,
Yes, sir.
and source charge and this point Q. Distance between Q and Q naught.
So you can scroll down.
Mhm. Electric field can be written in this form also, in vector form. But you will always take here Q naught test charge,
Yes.
and that too very small.
Okay. So you can scroll down.
Of course. So there can be the two definitions of electric field. First is it is a space around a charge in which the test charge experiences the electric force. Another is this is a force on a unit positive charge placed at a point.
So you can scroll down.
Because I'm zooming it out. Is it fine now?
Yes, sir.
Okay. Written?
No, sir. Can you scroll down?
Okay. So this is a source charge here. And you have to calculate the electric field at this point P, which is at a distance r. The formula is kq divided by r square. This is the magnitude. And if you want to write this in the vector form, then you will multiply this with a unit vector in the direction of electric field.
Yes.
This capital Q is the source charge
Okay, sir.
that generates the electric field.
So you can scroll down.
And this electric field is inversely proportional to the square of the distance. Means the electric field will decrease as we move away from the charge.
Yes, sir.
Okay. And for the direction, you can take the direction of electric force on the test charge.
Yes.
Yeah. And Ziyad, in the next class, revise your notes, okay?
Yes, sir.
When you will come to the next class, please revise your notes. Written?
Yes, sir.
Okay, Ziyad. So now you can leave, okay? That's all.